men. And as usual, I use the term loosely. We're here to chronicle a series of failures concerning this tool. This is the tool I use to remove cam bushings from can covers on iron heads. And you're probably, well, you may be familiar with the principle. Anyway, you knock the tool into the bushing. The fingers expand when it comes out the other side. You put an arbor down the middle of it, and that keeps the fingers from compressing. It's installed in the part somewhat like this, and you use a nut to pull the whole arrangement out of the cam cover. Anyway, that's the principle upon which it works. This is the original one of these, and somewhere along the line, I lost or misplaced the arbor that goes down the middle. And I happen to have a piece of 3/8 round bar laying around. And I thought, no problem, I'll just lop off another 6 or 7 inches, whatever it is, and have another one. Well, as it turns out, when I made this one originally, I think I must have drilled the hole from one side and then from the other side, and they didn't quite line up in the middle. So when I got my new 3/8 inch bar to shove in there, it won't go through all the way. And I thought, well, no problem. I'll toss it on the lathe, run a drill bit down through there, clean a hole out, and everything will be good. Apparently, when I made this, and I think I made this out of an old bolt, probably because I didn't want to cut threads and I had the right threads on it. I don't remember. But anyway, this tool has been in service for quite a while. Anyway, so when I went to drill a hole down the middle of it to straighten this out, this thing had been heat treated, hardened, and tempered, and the driller got so far down and it wouldn't go anymore, and it got jammed up in there. I couldn't penetrate through the hardening, and when the drill locked up on the shaft, the lathe chuck was rotating, and it grabbed the corner of one of these fingers, and it spread it and tweaked it and made it all cattywampus over here. Functionally, this thing probably would still work okay. I just didn't like the looks of it anymore, so I decided to make a new one. And thus began a journey of failure, so to speak. Here was the original one that I screwed up. I'll call that failure number 1. Here is failure number 2, and this is kind of interesting. I made this out of a piece of bar stock I had laying around, and when it came time to cut the slots, I decided I wanted to do it differently than I had on the original. On the original, I took a couple of cutoff wheels, I put them in my drill press, and fed the tool into it and cut these slots. And it worked okay, but the toxic dust coming off of this thing was everywhere. It just was not a very elegant solution. So I wanted a little more refined way of doing it. So I drilled a bunch of little holes in here, 1/8 inch holes, just barely touching on each other, 4 spots all the way around. And then I ran a 1/8 inch end mill through here to smooth it all out. Well, it didn't work real well. It left rough edges. The metal must have had some stress in it, whatever, and it kind of tweaked it all, and it came out weird. Nonetheless, I thought I would try to use this thing. So I heated it up red hot, threw it in a bucket of water to temper it, checked the hardness when I was done with it, and found out that it wasn't hard at all. Didn't even do anything to it. So I decided to heat treat it again because maybe it hadn't gotten hot enough. So I went back to reheat it, and I brought a magnet with me so I could check the magnetism, because you heat them up until they're hot enough to lose the magnetism. I decided to check it before I heated it up. So I got a magnet out there and discovered, guess what? This piece of metal's not magnetic at all. So I started thinking about it, and I made this out of a piece of steel round stock, that I got at an estate sale, and I picked out of a bin of rusty steel bars. And I picked this steel bar because it wasn't rusty. And I thought, that's weird. All that other steel's rusty. This one's not. Let me grab that. It must be something special about it. And I think what was special about it is that it's a piece of 300 series non-magnetic stainless steel. And non-magnetic stainless steel can't be hardened by heat treating. Plus, stainless steel is just not a good choice for this kind of a tool. Stainless steel galls when it's under a lot of load. And if you're putting a nut on it and tightening it to high torque because you're pulling against a fixed stationary object, the bushing, it's going to gall. So stainless steel is a bad choice to use. So failure number 2. Failure number 3. And this is really getting to be irritating because I've got a lot of time invested in this thing by now. Failure number 3. I've got a stash of water hardening drill rods that I do some machining on because it's easy to work with and theoretically it's hardenable. So anyway, this is a piece of water hardening drill rod. So I made the part. I used a slitting saw to cut the slots in it. I was very happy with the results. Dimensionally, it worked real nice. It was the right size, the right shape. The threads were good. The area with the slots, the fingers was nice and flexible. Heated it up red hot, threw it in a bucket of water to quench it, and immediately discovered 2 problems. The first immediate problem was, well, since I've broken it, you probably can't tell. The first problem I encountered was that the part was bowed. The heating it up and quenching it bowed it. It warped it. It was bent. Bad enough, okay? And you probably can't see this on camera, but right in through here, this thing is cracked. It cracked as a result of the heat treatment, so the part was junk. Anyway, I thought I would try to straighten it out just to see if it could be straightened. So I heated this area in here, red hot again, held this end of it in a vise, stuck a bar in the piece of red hot steel, and tried to straighten it out. And it broke. Cracked, broke right in 2. Surprisingly easily, too, I might add. So, you know, another, I don't know, 3, 4, 5 hours of making this thing down the shitter. Failure number 3. So, in the spirit of try, and try again, I decided to go for a 4th attempt. This is the story of the 4th attempt. So the 4th time is a charm. I'm not going to use water hardening drill rod. I bought the water hardening drill rod. I got 3 or 4 sizes. I used it for some other projects that I had going on, and for the other project it works pretty well, but it's really not going to work for this project. So I went out and I bought a piece of 41L40. So it's 4140. It's relatively high carbon content. This part should harden up real nice. The L means it's got lead in it, so it should machine easier than 4140. So I bought this material to make the 4th attempt out of, but you know what? We're not going to use it. We're going to use this. And I'm sure you people think I'm crazy, but we're going to give this a try. I like to go for walks, and I want to run by the railroad tracks. And this is, I believe, a bolt that holds the side plates to the rails to tie the rails together. And my reasoning is that this must be a pretty good hunk of steel if it's meant to hold rails together with, you know, 1,000,000 pounds of train. And why do it this way? Well, because this is the internet and this is YouTube. And people do stupid shit on YouTube all the time. And my reasoning for using this is that if it machines well, it should be sufficiently strong in its current state without having to do any hardening or anything to it, because hell, it holds rails together. So we're going to go make a new one of these things out of this old bolt and see what happens. Okay, I've been whittling on this thing for a while. I got a brazed on carbide over here, barely any radius on this thing. I'm taking 20 thou off per pass. It's machining halfway decent. The finish is halfway good. I got obviously a bunch more to do, but this might work. I got a long way to go. So far, I've spared you the agony of watching the tool pass back and forth across this chunk of steel. But anyway, we're going to keep on sawing away over here and see what we get. All right, you should be able to see I got the big knobby end off the bolt turned down. I got to shave this whole thing down to 0.625 5/8. That's the inside diameter of the bushing. So about a gazillion passes from now. I've been taking 20 thou off at a time. So anyway, I got to get that going. So let's get it set up and take a few. All right, well, a new day, so hopefully I'll get this finished up today. This has got to be threaded for this nut, 5/8 18. I'm going to neck the diameter down in this area to 0.550, and that's going to do two things. It's going to give me an area that the cutting tool could overrun when the threads end over here. And then I've got to slit this end to create the fingers. So the neck down area will make this part more flexible, so it will more easily squeeze together when I punch it into the hole. Anyway, out to the lathe. Let's go drill a big long hole down the middle of this thing. I gotta touch up the center drill over here, and we'll start drilling a hole. And that's that. We have a hole. All right, here's where we're at. Off camera, I just ran this tool in like this to put the chamfer on there. I think that'll work just fine. The next thing I'm going to do is reduce the diameter between here and here. And that'll give me an overrun for the threads I'm going to cut at this end. And it'll thin this up to make it more flexible for these fingers to pop in there. So we got to go from 0.625 to 0.550, so that's 75 thou. And okay, we're going to cut some threads. I've got my gear selected. I've run a scratch pass. We're going for 18 threads per inch. I got my thread gauge, and it is in fact coming out at 18 threads per inch. We're going to run the first reel pass, and I'm going to take a 3/1000th cut. So let's hope I don't fuck anything up. Looking good so far. All right, we're going to back the cross slide off. Go back to 0, and we'll take another 3/1000ths on the dial, and we'll put a couple of drops of juice on it. Waiting for the dial to come around. There we go. All right, we're to the slot cutting operation. I ran the slitting saw down until it just touched the top of the collar block over here. And I did that with just a piece of cellophane plastic between the two things. So when I could just tug the plastic out, I knew that the saw blade was probably within 1/1000th of an inch of the top of this. So this thing is 1 3/4, so half of that is 0.875. The saw blade is 1/8 of an inch thick, so half of that is 0.062. Added the two things together, came up with 0.937. Lowered the quill 0.937 from the top of this, so I should be in the middle of my tool. Calibrated eyeball check says it looks good. So we'll turn it on and we'll see what happens. Let's flip this thing 90 degrees. Okay, I suspect that as I cut more fingers into there, vibration is going to become more and more of a problem. So what I've done is I have a Sacrificial Arbor that I'm going to shove down the throat of this thing. Sacrificial Arbor shoved down the throat, and I have a collar with the set screw on it with the slot cut in the middle so that the slitting saw could go through the middle of the collar. And I'm going to tighten the set screw, and that should lock the fingers in alignment while the saw is cutting through everything. Anyway, calibrated eyeball test says that looks good. Lock this back down. And take one more pass with the saw. All right, here we go. Nice so far. One last finishing step. I need a couple flats on the sides over here because every once in a while when I'm tightening the nut down, I gotta keep the middle from rotating. Okay, I want to put a couple of flats on here, and I want the flats to fit a 1/2 inch wrench. So 1/2 inch is 4/16. The diameter of this threaded portion is 5/8, 0.625. So I'm going to need to remove about 62 thou from each side. So I'm going to go and crank the quill down until it touches this threaded part. I'm going to zero the quill and then come down another 60. I'm going to leave myself a couple of thou to play with. I'm going to come down 60, flip it over, and do the other side, and I should be within a thousandth or two of where I need to be. So let's try that out and see if it works. Very good. This is done. Let's take it inside and take a look at it. Okay, let's wrap this project up. Here's the original tool. It served me well for many years until, of course, I screwed it up and I sprung these fingers. And actually, these fingers being sprung really would not have prevented me from using it, but I just wanted to make a new one. So anyway, we'll call this fail number 1. Fail number 2, made this out of stainless steel. Didn't know it was stainless steel I was working with, but apparently it was. Dimensionally and such, the tool is actually okay and probably would work fine. I just didn't like, I got kind of a rough finish down in here from, drilling all the holes in and milling it out, didn't quite clean it up. Functionally it probably would have worked okay, just wasn't real happy with the finished result overall. Number 3, and you saw this earlier in the video, and I referred to a crack in this area. Well, I just put it on a vise and I exerted a little more force on it and I got it to pop over. So the attempted heat treating this piece of water hardening drill rod actually, I think, cracked it in 2 places. See this smooth area right here and this area in here. These cracks, I believe, happened when it got dropped in the bucket of water. This grayed out area and rough fracture was kind of the part of instantaneous failure. And, once it cooled off and I was mucking around with this, this broke off easily. I mean, there was not much strength left in there at all. But it was cracked. Crack started here, and then I finished it off. And then I just, like I said, just put it in a vise and bent on it a little bit to open up this other crack that was under, it was there. It was kind of a tight crack, but it was there. But anyway, a failure was imminent. The steel was a lot tougher down and through here. This was actually pretty hard to get it to break like that, even though there wasn't a lot really holding it left together. So there's some variation in the quality or the strength of the material, I'm supposing due to the crude and ineffective quenching and heat treating. Anyway, failure number 3. And finally, the 2 finished products. This one was the one that was made out of that railroad rail tie bolt, and I'm pretty sure that's what it was because I found a sling on the ground next to some tracks that were being worked on, And, you know, this is just like the bolts that tied the side plates to the rails. So, as I stated in the video, if this thing could hold, you know, 1,000,000 pounds of locomotive and 100 boxcars after it, this has got to be some pretty tough stuff. I'm really surprised it machined as easily as it did, but I'm very happy with the overall finish, the ease with which it machined. This worked out very good. It's going to be a good tool for me to use. This one here was made out of a piece of scrap from my scrap pile. It worked out pretty good too. It was heated up red hot, quenched in oil. It was oil quenched. It really isn't any harder or much harder than it was when I started out, so I suspect this was a low carbon steel. But anyway, it should work fine. Usually these bushings are not, you know, they're not usually very tight, so this, I think, will work fine. The threads on both of these, I've already used both of these, but the threads on both of these are slobbered up with anti-seize compound. Anytime you're using a gear puller type thing, the pulling screw or the pushing screw should have some kind of anti-seize lubricant on it, because you can seize the screw into the device and ruin the threads, and then you'll be out the tool. And just FYI, I've been a mechanic for 46 years, and I know that you could go buy what are typically called pilot bearing pullers or blind hole pullers for just a few bucks on Amazon. So if you added up the hours of making these things times an hourly rate, I could have bought many Amazon blind pullers for what time it costs to make these two things. You know, it really wasn't about ending up with the tool. It was about the making of the tool. And I learned quite a bit in this process, and it was a lot of fun. So I would do it again in a heartbeat, no doubt about it. In the meantime, I am out of here. Hey, thank you all ever so much for watching. I really appreciate it. Please subscribe, and we'll see you next week for the next one. Thanks. Bye.